Hello, today I will solve IMO Shortlist 2018 G4. This problem was given to me at my last TST and I have solved this very fast, and this problem gave me a chance to become a member of my team and represent it to the IMO. So that's why I like this problem very much. We are given any random point T inside the triangle ABC, and it was reflected to every sides AC, BC and AB, and C1, B1 and A1 are these points. And if we take the omega cycle, which is the circumcycle of C1, A1, B1, and take the intersections of A1T, B1T and C1T and call them A2, C2 and B2 respectively, then we get that then we need to show that AA2, BB2 and CC2 must be conquered on this omega cycle. The first idea, what I got about when I see this problem, was that it must be used spiral similarity in this problem, because when we are given that three lines conquer on the cycle, this means that spiral similarity will be very useful here. And I tried to search for some similar triangles, and the first one was, then I decided that C1BA must be similar to C1B2A2. And now how can we prove this one? Now look at angle C1BT, C3BT, angle C3BT. This equals angle C1B C3, because C1 is reflection of T over AB. So if we assign both of these angles beta, now we can see that TC3BA3 is cyclic quadrilateral. So angle TBC3 equals angle TA3C3. Call this B. And because we know that A3C3 is parallel to the A1C1, this means that angle C1A1T must be also beta. Angle C1A1T must be also beta. C1A1T must be also beta. And we get that if we look at triangle angle C1B2A2, C1B2A2 must be also same angle, because this is half of arc C1A2 on this omega cycle, and this equals 2 times beta. Arc C1A2 is 2 times beta, so C1B2A2 must be beta also. Similarly, we will see that angle C1AB equals angle TAB. So if we assign this as alpha, this would be also alpha. And how can we prove that this angle would be also alpha? And to prove this, we need to take C1, C3, B3, so cyclic quadrilateral AC3, TB3 gives us the property that angle C1, B3T is also alpha, so C1, angle C1, B1, T equals alpha, so arc C1, B2 must be 2 times alpha. So from here we can conclude that C1 B2 is 2 times alpha, and angle C1A2 B2 must be alpha. Clearly we get that these two triangles are similar, and this was all we wanted to show. And now the remaining thing is about the technique. Angle CAB, C1AB was similar to triangle C1 A2 B2. And what can be said about this thing is that these two things are spiral similar, and this means that BB2 and AA2 must be conquered on the cycle. I have recorded the video about the spiral similarity in the theorem playlist. You can also this one, I will link this in the description, or I can show the small sketch about this one. If we are given two cycles which concur in points x and y, and we are given two lines which concur at x. Call this K, L, M, and we will say that y is the center of spiral similarity, which takes KL to NM. And why it is correct? Because if we look at angles YKL, this angle clearly equals this angle, and we get almost the same picture in our problem. We are given two similar triangles and one point was on a cycle, and if we take the circumcycles of C1 AB and C1 A2 B2, this point must be the intersection, which gives us that this must be the intersection of BB2 AA2 and cycle C1 AB. These 3 points must be on the omega cycle. So we have shown that BB2 AA2 concur on the omega cycle. We will do the same operation for BB2 and CC2 and AA2 and CC2. So we have proved that all these 3 lines concur on the omega cycle. And this was all the problem wanted to prove. If you got any questions about the spiral similarity or angle chasing, please write in the comments and I will try to answer you. If you liked my solutions, please write in the comments and don't forget to like and subscribe.